Our objective as a company is to find the truth by examining the evidence in a faithful manner, and when we find the truth, to be able to present that truth in a clear and concise way. In 2003, Origin Engineering was formed. In 2015, at the end of last year, we changed the name from Origin Engineering to Origin Forensics, and the reason why we changed the name to Origin Forensics is because we don't really do any engineering. But what we do a lot of is forensic analysis for a lot of different cases. Our biggest client is Ford Motor Company. That's who we do the most of our work for, and products liability lawsuits around the country. When people ask me, where have you worked? I've worked as far north as Fairbanks, Alaska, and as far south as the tip of Florida. What we're here to talk to you guys about today is, well, in part is that van as well as all the equipment that you see that we've got staged around here. This is a demo of our technology for a new era in rapid response and data collection for accident data preservation. We want to try to take and pull in the technologies that are available that allow us to collect forensic data at a crash site quickly and efficiently. And we want to try to show you guys what we've been able to pull together here today. We're trying to figure out how we were going to put this demo day on. So we decided the best way to do that was to buy a couple of crappy old vehicles and wreck them, and then document the outcome.
All right, here I come.
Start to see is you can see exactly what it did right before impact. This is the right rear, that's the left rear. Here's the left, here's the right front, and the left front is over there. You're talking about why did it go over there? Yep. Because I was already yawing that direction when I hit. Right, and then with the rear brakes active, it just accentuated it.
Yeah. You know, as you're driving the car in through here, you have no idea what you're going to do in that split second, and when it happens in your mind, you're like, no, I drove straight in.
Yeah.
So it's fascinating to see the evidence tell the story when it's driving.
Yep.
It's really fascinating.
Crash data is extraordinarily perishable. Data from a crash starts to degrade almost as soon as the crash is over, especially if it's in a highly trafficked area. Tire marks, debris patterns, those kind of things start disappearing right away. We can efficiently collect a significant amount of forensic data at a crash site, both from the site itself as well as from the vehicles, and we can do it in a cost-effective manner. Top level item we have here is our SenseFly Exome, which is now called the Albris Unmanned Aerial Vehicle, or in more definitive terms, an SUAS, Small Unmanned Aerial System.
Say there was a lot of extra topography out there, it would create a three-dimensional map of all of the terrain change and everything. It gives you another way of collecting data at a crash site. The drone actually does it much quicker because you can just fly a pattern in like 10 minutes and it collects all those photographs. So if you could give the police a giant photograph of the whole area that looks like it was taken from the top down, they could take any measurements they want, anything like that, from that singular photograph. So there's a lot of things that we can do.
And we also have our Faro laser scanner, the X330. We can do an efficient and accurate 3D mapping. This scanner, when we have it set up in its typical mode, is about 44 million points per scan. And you can stand at the location where the scanner is and then move the iPad around, and with that app you can see the panorama around you of where the scanner was at the time. We have a Scene Pro CI200. It's an integrated video, GPS, inertial navigation system. And say you go do a brake test and you want immediate output of that brake test. You hit print, this prints off in the battery box and it's right there, and you just tear it off just like you're tearing off a receipt. What your slope was on the area where you tested, how much distance you traveled, your total path distance, forward distance. So it's accounting for elevation changes. The brake testing is sort of one component. But the rest of it is you can do basic vehicle handling and dynamics. Say you want to know how a vehicle is going to handle if you've got low air in one tire and you're doing turns. The other thing we can do with the vehicles is we have a Bosch CDR tool. That tool, we can plug it into the vehicle or into the vehicle's emergency data recorder, and we can take a snapshot or an image of the data that's on that emergency data recorder.
So we got 42 miles an hour at impact. Just right 1 second before impact. Okay, good.
You want to have your data available as soon as possible so you can start making decisions. It doesn't matter whether you're in law enforcement, whether you're an attorney representing a client or an insurance company. If you have an ability to get out there and collect it quickly and efficiently and do it within a few hours, when the vehicles maybe are still there or maybe the day after, you can collect that data really quick and then store it and preserve it so it's just like the crash just happened, because now you have that data there in the future. Veritas, Fidelitas, Claritas. Veritas means the truth, Fidelitas means faithfulness, and Claritas means clarity. That's what we're all about. We want to try to gather as much evidence as we can, understand the truth of what happened in a given accident by examining that evidence faithfully, and then be able to actually share our knowledge after we found that truth, after we found that information.